And as we can see, we have solved 31 plus 1, 32 problems till now, and we are going to today continue solving more problems. So maybe we'll solve 1 or 2 problems depending upon the amount of time it takes to solve each of the problems, and we will see how many we can solve today. Possibly 1 or 2. Okay, so let's take a look at the next problem. This problem is problem number 32, and before we read this problem, let me start a new file over here. We call it problem 32. Problem 32, there you go. And let's copy the problem over here. That's problem 32. Let me reduce the size of this a little bit. Okay, and this would be called pan-digital products. Okay, we'll figure out what that means. There is a hint, so this is probably a difficult problem. Okay, we shall say that an n-digit number is pan-digital if it uses all digits 1 to n exactly once. Okay, for example, the 5-digit number 1 blah 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 through 5 is pan-digital. 1, 5, 2, 3, so it has all the numbers from 1 to 5. Okay, the product 7254 is unusual, as the identity 39186 7254 contains multiplicand, multiplier, and product. So that one, and that, and is 1 through 9 pan-digital. So if you take 39, 186, and 7254, I am guessing that we will contain all the numbers between 1 and 9. Okay, so that's 1 through 9 pan-digital. Okay, find the sum of all products. Sum of all products, okay, whose multiplicand, multiplier, product identity can be written as a 1 through 9 pan-digital number. Okay. Some products can be obtained in more than one way, so be sure to only include it once in your sum. So this product can be obtained by 2 different combinations, so we need to include it only once. So that's the goal over here. So we can do a brute force, but that's not very interesting. Let's open our notebook and see what we can come up with for something like this. We want to create something that is where doesn't it turn? Okay, there we go. We want to create something that is let me see. I need to mirror my screen. Okay. Let us try and figure this out. Let's see. The simple way is to find all pan-digital number, all permutations of the numbers 1 to 9, and the way that can be done is in Python. You have this thing called itertools. IT, and you can create permutations and you give the numbers. So 1 2 3 4 5 6 7 8 9, and this is a where's my mouse? Over here. Okay, yeah. So this, we can look at the first 10 of these. For I in range 10, and we can or we can even look at enumerate that, right? And we can say print v, and if I is greater than 20, so we want to look at the first 20 when click. So as you can see, we have permutations of all these numbers over here. So that's okay, and I believe for numbers like this, there should be n factorial permutations, so that's a lot of permutations. And 10 factorial is a really big number. So in this case, 10 factorial, I believe factorial 10 is a really big number. Well, actually, it's not so big. We can brute force this, I think, but the other thing we have to think about is which are the numbers that will contain that should contain meaningful subsets that we want to look at. Because even if we get a set of numbers like this, then we have to figure out two other places to cut, like here and here, and the multiplication of these two has to give this. So it's not just this many combinations. It's not just that many different permutations, but within each permutation we have to check a number of different possibilities. So that's one of the things that we have to see. So we want to see whether we can reduce the amount of time that we are looking at this by reducing things that we don't need to check. So a couple of things. Let's look at, okay, so we are over here. Let's look at a couple of things. Let's say A times B equals C. So if we take a number like this, if we take a number like 39 times 186 equals 7254, let's say, then under these circumstances, if you look at this one and this one, then you will see that this 2 multiplies and gives a 54, and the unit of this belongs here. So we know that we can only have 1 2 3 4 5 6 7 8 and 9, so we can only have those numbers, and the permutation of these numbers have to be such that this last digit cannot be just any number. So this last digit can only be one of a set of few numbers. So So for example, the last digit cannot be a 5. This one and this one cannot be a 5, and this one cannot be a 5. The 5 will have to be in the center somewhere, because if this is a 5, then one of these things will have to be a 5, and this will have to be an odd number. So but we cannot have 5 two times, so that's one of the problems of this. Okay, so let's try to figure out if we multiply a 1, 2, 3, 4 and all of that, and we multiply it by 1, 2, 3, 4 and all that, then what would be the last value for each combination? Okay, and we can see if there are only certain combinations that we can allow, and all the other combinations we don't even have to check. So let's try that first. Okay, so let's take a look at n's equals range 1 to 11, 11 like that. So for I in range 1 to 11, for j in range, okay, so we don't need everything. If we already have I, we don't need that anymore. So we will take a look at I plus 1 and j, 11 again. Okay, and let's see, print I, j and I into j. So let's see what this gives. So this gives a number. Oh wait, I don't want 11. I want things to go all the way to 10. Okay, 10 like that. Okay, so we have some numbers like that, but the last bit we want is, we only want the last part. So percentage 10 like that. So that's the modulus 10. Just to explain what this is, so we are extracting the last value over here. Okay, so that's basically what we're doing. And we want to see what are the combinations. Are all the numbers present? Are all the numbers not present? Are there certain numbers that are present? Are there certain numbers like this that will not be possible to look at, and so on. So these are all things that we have to make sure we take care of. So this I will call K. K is that. Okay, and if K is not equal to I, and we don't want them to be equal like that, like for example 5, and K is not equal to J, then let's look at those ones. Significantly smaller group, but it looks like all the numbers are over here, and k is not equal to 0. We can't have a 0. Smaller group, and k is not equal to 5. Correct? Ah, that's already taken care of. Okay, so what this is doing is we are trying to find values that can occur over here. Equals this, and then we will say this and k, and at the very end we will say list equals list and excuse me, list and set and k. Int object is not iterable. We are looking at this like that. Okay, so let's look at value list. We have 1, 2, 3, 4, 5, 6, 7 possibilities. These are the only 7 possibilities that are available for the last digit of the product, and the rest of the digits will be something else. The other thing to note is that these last digits can only occur for certain combinations of the last digits of the multiplicands. Okay, so let's actually find all of these things. So are these unique? I believe they are. Okay, so let's not just put k. Let's put the tuple I, j, and k. Lists are unhashable. Okay, and the value list will be that tuple. So what we have over here, let's sort it. Okay, what we have over here is a set of values that can only occur for certain values of other things. So there can only be one way in which a product can have a 1 at the end, is if the multiplier, yeah, the multiplicand and the multiplier ends with a 3 and a 7. So the rest of the items, which we only have 7 different values left that we can shuffle around. So that's a much smaller that's a much smaller set of numbers that needs to be shuffled around, given that we have this one, this one, this one. So that gives us some idea of how we can reduce the amount of computation that we need to do. Okay, so having said that, let's try to figure out how to solve this problem. So what we are going to do is we are going to start with a value list, and the value list is, so for let's take the first element of the value list, and we'll call that values, like that. Values is list 0. Okay, so the values will be something like that. And what we want to do is we want to find all combinations of things other than 1, 3 and 7 that will be part of this value list. So let's find other values equals I for I in range 1 to 10 if I is not in values, and if we print values and other values together, okay, values and other values together, we will see that we have 1, 3 and 7. So those are the 2 things that we have, and we have these other values 2, 4, 5, 6, 8, 9. We have to combine them in some way and come up with some sort of permutation that will give us the rest of the items. So okay, so let's figure out how we can do this. So for this one group, we are trying to solve for this one group and seeing whether that is possible. Let's take this one, for example, 9, 6 and 4. Do we have that? 6, 9 and 4. We have 6, 9 and 4. So instead of looking at this, let's look at the and 4, and we want to see whether we are able to find at least this, because we know that this is one solution. If we can come up with an algorithm that can identify this, then we know that we can find an algorithm that will be able to find all values of all other values. So how do we do this? So for this, what we want to do is we want to find all combinations of this, okay, all permutations of this, and we want to be able to, and for each permutation we want to be able to select a group of characters. So what do I mean by that? Now we have other values. We can look at it dot permutations of other values, and let's look at all of these things. So this is a fairly big list, right? So now other permutations, and within other permutations we will have a 3, a 1 8, and a 7 2 5 within there, and we need to be able to split them so that we can extract these things out. So let's take the first other permutation. So that's the group of characters, and we want to split it in 2 different places, and the way we can do that is we want to there's no point in, okay, so we can start with splitting with 0, the first pointer over here, then the next pointer also at 0, and then we will continue all the way until we find all combinations. So let's try to do that. Permutation like that, and for j in I plus 1 to the same, and I'll do plus 1, okay, and we want to say group 1 is other permutation all the way to I, and group 2 is other permutations I to j, and group 3 is other permutations to j onwards. We may need to add a plus 1 in some of these places. Let's take a look. Print g1, g2, and g3. Okay, so we start with nothing over here, then we have 1, and then 2 3 4 5 6 7 8, then we have 1 2 and 3 4 5 6 7 8, 1 2 3 and 5 6 7 8, 1 2 3 4 5 7 and 8, and then everything over here, and we have 2, and then we have 1, and progressively all. So this looks like we have all the combinations, and we haven't messed things up, so to speak. So Now what do we do? Now that we have these combinations, we want to convert it into a set of numbers. Okay, so G1 equals, we want to map this into a string, and then join like that. Similarly, we want to do the same thing for G2 and G3, G2 and G3, 3 and 2, and let's print this one more time like that. So we have nothing, 1 and 2 3 4 5, 1 2 and 3 5 7 8 all the way, and then over here we have 1 2 3 4 5 6 7 and 8 and nothing. It would be better if we just showed it like that, so it's easier to see that. We actually, there's a problem over here. It should be like that, not like this. And we see that we have all of these combinations, so we don't need to do this. Okay, so those are all the combinations for 1 2 3 5 7 and 8. And what we want to do is, at the end of it, we want to also add our current list for other permutations. So these are other values. Give me a sec. The values and values. So the values are V1, V2 and V3. Those are the values. So we want to create the list G1 plus equals V1, and similarly we want to create 3, 2, 2, and if V1 is not defined, equals values. So we have all of this, and we also want to print G1 plus G2 plus G3 to make sure that this is actually the right set of numbers. So 1 2 3 4 5 6 7 8 9, all of that. So we have all the correct numbers, and we have all the combinations that we need. So given this, okay, given that we have these three groups, now we want to convert these things back into integers. g1 equals int g1, and similarly g3 2 then 3. Okay, and we want to see whether g1 times g2 equals g3. We want to see that. Oh wait, nine and 6, 6 and 9. Nine, 6 and 4. Oh, this is only one of them. This is only one of the permutations, and there are many other permutations. Okay, so we have to look at all the other permutations. I was trying to figure out why this is not appearing. Okay, if that equals that, prints g1, g2 and g3. Nothing. We can check as a quick check. We can look at other permutation equals, and over here what we can do is we can say, so we are, for values we are looking at 6, 6 and 9, so we should put values 1, 8, right, 1, 8, 3 and 7, 2, 5, 7 and 2 and 5, and this should give us 186, 39 and 724. So it is this stuff is able to give us that particular combination. So given that we know one of the permutations is the right permutation, let's look at all permutations. For other permutation in other permutations, like that. Okay, we want to see whether we are able to find a set of permutations, and it appears that there is only one permutation over here that will give that. Okay, so now that we have this, we need to now find everything for all other combinations, right? So we don't need this. Okay, Okay, so now we have to put in another loop where we say for values in, and we have this entire value list like that. We want, and for these values we want to find the other values like that, other values, and we want to find other permutations for these other values. Other permutations for these other values, and given other permutations we have to loop through everything. So if we actually do that, and in this case let's look at the products, all equals like that, and if we get to this point over here we want to put the all products in there. So all append G3, that's the product. Okay, so if that happens, then we will add all the products, and then we will do this. This will probably take some time. Let's get tqdm from tqdm import tqdm, and this is tqdm. So this is just the high level values, and I can put another tqdm over here just to see where we are. Let's look at that. That's it. That is all. 1 2 3 4 5 6 7 8, and this appears like twice, this appears twice. Oh, okay, so this is interesting. Let's look at all products. This was pretty fast. I thought it was going to be much slower. That's that, all products, and all products equals list set all products. We want, and so these are the unique values. Okay, and then just the sum of this, sum of all that. Let's see whether that's correct. No, sorry, but the answer you gave appears to be incorrect. No. Okay. Let me do a quick check. 27 into 198 is 5346. 346. Okay. So it looks like it's getting all the things, but I might have made things a bit too complicated. Maybe I shouldn't have done all of this stuff. Now I feel that I have done, given the speed at which this finished, I might not have needed to do all of this stuff. So let's try to not do all of this and do everything in a simpler way. One to 10. That, and let's just brute force it. So all combinations, there are that many combinations, and current is all combinations. Current is all combinations 0, 0, and I want to find ways of splitting this. So for I in range, what did I do? 0? Okay. For I in length of range of 10. Okay. For j in, what am I doing? I plus 1, I plus 1 to j. Oh, I plus 1 to 10 again. G1 equals all the way to I. G1, G2, and G3 equals this, that, I to j, and then j onward. G1 equals map str what is this called, G1, and join like that. G3, G2, G2, G3, print G1, G2, and G3. Huh. I has to start from 1, and if I do that, 1, this, and there's 1 over here, and 9. That will give ample opportunity no, this should also go up to 9. Okay. This has to be converted into an integer. Oh. Let me do these are all now integers, and if g1 into g2 is g3, then print that. So nothing over here, and the current is this for in everything. I want to see if I get more things in all combinations, like that. Wow, I'm getting many more. Okay, I'm at 4. Okay, so I want to find all products. All is that, and if this is the case, I want to say all products dot append g3. Let's do it one more time. Did it find 39,186? Oh, it did. It did find 39,186. So on. Okay. And all products is that it's that big list, but it's oh, 1 2 3 4 5 6 7 instead of 1 2 3 4 5 6. Okay, I missed one. 7 8 something. I missed this for whatever reason. 2 was 2 eliminated? No. Huh. What's the sum of this? That. Okay, let's try this. Oh. Okay, so I tried to be too fancy over here, and I have to figure out what I did wrong over here. There is one value I missed. which is 7 something something, the last one, and I have to figure out. But anyway, so it's already been, what is this, close to an hour, so I will stop over here and we will continue next time. And if you like seeing me solve problems like this, then please like and subscribe so that you can look at similar problems. Anyway, so much for today. Take care. Bye bye.